Space is terrifying, but fascinating. Among the most mysterious objects in the universe are black holes, cosmic monsters that swallow everything in their path. But have you ever wondered what happens inside a black hole? Today, we're going beyond the event horizon to uncover the terrifying secrets hidden in the darkest corners of the universe. Black holes are among the most mysterious and powerful objects in the known universe. But how do they even form? It all begins with a star. Not just any star, but a massive one, at least 20 to 30 times the mass of our own sun. These stars burn bright and fast, fusing hydrogen into helium, then heavier and heavier elements in their cores. For millions of years, a battle wages inside the star, gravity pulling everything inward, and nuclear fusion pushing outward. But eventually, the fuel runs out, and when that happens, fusion can no longer hold back the immense pull of gravity. The core collapses in on itself at incredible speed. In a fraction of a second, the star implodes, triggering a violent supernova explosion that blasts the outer layers of the star into space. What's left behind is unimaginably dense. All that matter collapses into an incredibly small, incredibly heavy point, what scientists call a singularity. It's a place where the laws of physics as we know them simply break down. Around that singularity is something called the event horizon, a boundary that marks the point of no return. If anything, matter, energy, even light gets too close and crosses the event horizon, it's gone forever. That's why we call it a black hole. It doesn't reflect light. It doesn't emit light. It only swallows two observers from the outside. It appears invisible, like a hole torn into the very fabric of space-time itself. But what lies beyond that darkness is even more strange and terrifying. Now let's say you're incredibly brave or incredibly unlucky, and you're falling into a black hole. Your feet first, slowly drifting toward the event horizon, the invisible boundary around the black hole where escape becomes impossible. But something strange begins to happen. Gravity isn't acting on your whole body equally. Because your feet are slightly closer to the black hole than your head, the gravitational pull at your feet is much stronger. So strong, in fact, that it starts to stretch you out. Not just tug, not just pull, stretch. This process is so bizarre and extreme. Scientists gave it an equally bizarre name, spaghettification, because that's exactly what it looks like. Your body begins to elongate, stretch thinner and thinner like a strand of spaghetti. The closer you get to the center, the more intense the tidal forces become, until your body is torn apart atom by atom. It doesn't matter what you're made of: flesh, bone, titanium, even solid rock. Spaghettification doesn't discriminate. It's not just science fiction, it's real physics, predicted by Einstein's theory of general relativity, and backed by the calculations of physicists around the world. What's terrifying is that this stretching happens so fast, you'd have no time to process it. From the outside, an observer might see you freeze in time at the event horizon, slowly fading into red before disappearing completely. But for you, time would feel normal. You'd be falling, stretching, dissolving, all while space itself collapses around you. Spaghettification is not just a cool word. It's a reminder of how alien and extreme the universe can be. And if that sounds like the worst way to go, just wait until you hear what might happen after you're inside. At the very core of a black hole lies something so strange, so extreme, that even our most advanced scientific theories begin to fall apart. It's called the singularity. This is not just a small object, it's a point. A single point where all the mass of the black hole is concentrated. Imagine compressing an entire star, millions of times more massive than the sun, into a space smaller than the head of a pin. That's the scale we're talking about. At the singularity, gravity becomes infinite. Space-time, the very fabric of reality, no longer behaves in ways we can predict. Time stops. Space curves so drastically that it folds in on itself. It's a place where all known laws of physics, including Einstein's general relativity, simply break down. We don't know what's really there because we can't. No signal, no information, No light escapes the singularity. All we can do is theorize. Some scientists believe that the singularity is a mathematical edge, a place that marks the limits of our current understanding. Like a glitch in the code of the universe, it might not be a physical object in the way we understand things, but a kind of cosmic blind spot. Others speculate it could be something even stranger, perhaps a gateway to another universe, a shortcut through space-time, or even a completely new kind of dimension. Could black holes be portals, wormholes, time machines? These ideas are still in the realm of theory, but they reflect just how little we know and how much we want to understand. There's one more thing to consider. If you reach the singularity, assuming you could survive spaghettification, you wouldn't just be dealing with immense gravity. You'd be entering a realm where cause and effect no longer apply, where the past, present, and future might all collapse into a single moment. It's the ultimate unknown. And the most terrifying part, the singularity is hidden. It's shielded by the event horizon, making it invisible from the outside. Everything we see, everything we think we know, is based on what happens around it, not within it. In many ways, the singularity isn't just the center of a black hole. It's the center of cosmic mystery, a place where science meets silence, where our greatest equations end in question marks. Time, as we know it, ticks forward steadily, 1 second at a time. But near a black hole, time begins to behave very differently. Thanks to Einstein's theory of general relativity, we know that gravity affects time. The stronger the gravitational field, the slower time moves, and black holes, they have the most extreme gravity known to exist. Imagine watching a person fall toward a black hole from a safe distance. As they get closer and closer to the event horizon, the boundary of the black hole, you would see their movement slow down. Their body would stretch due to gravity, but their motion would seem almost frozen. Their clock ticks slower and slower until eventually it appears to stop entirely just before reaching the event horizon. But from their point of view, time feels completely normal. They're falling, perhaps terrified, but unaware that to the outside world, they've essentially stopped in time. This isn't science fiction. This is a real effect, confirmed by physics and observed in milder forms near massive objects, like planets and stars. GPS satellites even have to adjust for time dilation due to Earth's gravity. But near a black hole, the effect is pushed to the extreme. Time and space stretch, bend, and eventually collapse. Some scientists believe that time may actually stop at the event horizon. So when we say black holes warp reality, we mean it. They don't just twist space. They twist the very flow of time itself. While black holes are often seen as terrifying endpoints, cosmic vacuum cleaners that destroy everything, some scientists believe they could be something else entirely, gateways. Enter the theory of wormholes. A wormhole is a hypothetical tunnel through the fabric of space and time, like a bridge connecting to distant points in the universe, and inside a black hole. Under the right conditions, some physicists believe such a tunnel could form. This isn't just science fiction. Wormholes naturally rise as mathematical solutions in Einstein's field equations. They're incredibly unstable, but possible, theoretically. If wormholes exist inside black holes, falling into one might not mean total destruction. Instead, it could be a one-way trip to another part of the universe, or maybe a parallel one, another timeline, another dimension, entirely. Of course, we have no evidence this actually happens. It's all theoretical, but the implications are staggering. What if black holes aren't just ends, but beginnings? What if they're portals to a multiverse we've only begun to imagine? One thing is certain, black holes don't just bend space and time. They bend our understanding of reality itself. We may never know for sure what happens inside a black hole, but that's the beauty of space. Every answer leads to more questions. The universe is a mystery, and we've only just begun to explore it. If you like this deep dive into the cosmos, don't forget to like, subscribe, and hit the bell icon for more mind-bending space content. Until next time, stay curious.